A research team has made a discovery that could change our understanding of the cosmos. They have identified 7 mysterious stars that may be part of a groundbreaking theory about extraterrestrial life. These celestial bodies exhibit inexplicable heat radiation, which could indicate that they are surrounded by massive, artificial structures, perhaps even Dyson spheres. If this theory is correct, it would offer the first clear evidence of extraterrestrial civilizations, and it might also reveal that these beings are far more technologically advanced than humanity. The concept of Dyson spheres was first introduced by physicist Freeman Dyson in 1960. His idea was not to design a specific blueprint but to suggest that an advanced civilization might build a structure to capture the energy emitted by their host star. The concept involves a megastructure, like a shell or a swarm of satellites, surrounding a star to harness its power. Dyson's idea proposed that if such a civilization existed, we could detect their presence through infrared radiation emitted by the structure as it absorbed starlight. Despite the theoretical promise, Dyson spheres have not been found. However, a recent international study has provided a new twist to the ongoing search for these megastructures. Researchers from Sweden, India, Great Britain, and the USA have scanned the infrared data from telescopes like Gaia, DR3, and WISE, analyzing over 5 million stars. They were looking for infrared signatures that could indicate the presence of Dyson spheres or similar megastructures. After filtering out common natural sources of infrared radiation, the researchers found that 7 stars displayed strange behavior that couldn't be explained by known natural phenomena. While no clear evidence directly linked them to Dyson spheres, the stars emitted significant infrared radiation, which is a crucial aspect of Dyson sphere theory. This discovery, published in the monthly notices of the Royal Astronomical Society, has sparked debates about the possibility of finding alien megastructures in our galaxy. These 7 stars are all red dwarfs, a type of faint star that rarely shows characteristics such as dust or debris disks. Normally, these disks would be responsible for the infrared radiation, making the findings all the more puzzling. The fact that these stars are red dwarfs, and yet they radiate significant amounts of heat, suggests that something unusual might be at play. The scientists did not jump to conclusions. They were cautious in interpreting the data. The infrared radiation could still be the result of unknown natural phenomena. For instance, it could be caused by dust clouds or nebulae, which are often sources of infrared emissions. However, the unusual characteristics of these stars suggest that they could be linked to something more extraordinary. An interesting follow-up study explored the possibility that these stars are connected to a phenomenon known as hot dogs in astronomy. Hot dogs are not edible treats, but rather a term used to describe a rare type of galaxy. These galaxies have dust-obscured regions with active galactic nuclei, meaning they contain supermassive black holes at their centers that emit vast amounts of radiation. This radiation heats up the surrounding dust and gas, releasing huge quantities of infrared light. The astronomers found that 3 of the stars in the study were near these hot dog galaxies. The infrared radiation detected around the stars could, in fact, be coming from the dust and gas associated with the nearby active galaxies, not the stars themselves. The researchers suggested that if these stars were located behind such galaxies, the radiation would appear very similar to what would be expected from a Dyson sphere. If this theory holds true, it would mean that the infrared signatures previously thought to be from Dyson spheres are actually the result of interference from distant hot dog galaxies. The remaining 4 stars in the study could also be influenced by these galaxies, though the astronomers have not yet pinpointed which galaxies are responsible for the infrared emissions. In light of this, the question arises, should we continue searching for Dyson spheres? The difficulty of finding evidence for such structures is significant, especially since we do not know how common they are in the universe. However, the development of advanced detection methods, like the use of infrared telescopes, has made the search for these signatures more feasible. Although we may not have definitive proof yet, the hunt for Dyson spheres and similar structures could be a valuable avenue for understanding extraterrestrial intelligence. The search for extraterrestrial life is ongoing, and while the James Webb Space Telescope primarily focuses on the search for biosignatures in planetary atmospheres, the discovery of a Dyson sphere would mark a monumental shift in our understanding of the cosmos. It would indicate the presence of civilizations far beyond our own technological level. Even if the stars do not harbor Dyson spheres, this study has provided valuable new insights into the nature of red dwarf stars and their potential infrared emissions. These findings may help astronomers refine their models of star formation and the characteristics of distant galaxies. While the possibility of discovering Dyson spheres remains speculative, the research conducted by this international team has introduced a fresh perspective on the nature of extraterrestrial megastructures. The stars they identified with unusual infrared radiation patterns present a fascinating case study for astronomers. Red dwarfs are typically considered the most common stars in the universe, but their faint luminosity makes them difficult to study. Yet, the peculiar radiation emitted by these specific stars could offer insights into the hidden activities surrounding such stellar bodies. Even if the stars themselves aren't part of a grand alien construction project, their behavior challenges our understanding of how stars and galaxies evolve in terms of energy consumption and distribution. The importance of the infrared radiation signatures cannot be understated. If a Dyson sphere were to exist around a star, it would absorb most of the star's light, converting it into energy, and inevitably releasing waste heat as infrared radiation. In this case, this study could mark a significant leap in refining our methods of detecting extraterrestrial technologies. Until now, efforts have primarily focused on identifying signals from alien civilizations in the form of radio waves. However, as Dyson originally pointed out, infrared radiation could offer a more promising and less obvious clue to the existence of advanced technologies that harness stellar energy. This finding opens up a new frontier in the search for extraterrestrial intelligence, SETI, expanding beyond just radio signals to include more diverse forms of potential detection. One of the key challenges faced by the research team was the need to distinguish the infrared radiation from natural cosmic phenomena. Galaxies, particularly those with active galactic nuclei, AGNs, can produce intense radiation that may mimic the characteristics of a Dyson sphere. These hot dog galaxies, which are composed of dust and gas heated by their central black holes, could emit similar infrared radiation, leading to confusion in identifying true megastructures. Nevertheless, the study's careful approach in sifting through millions of stars, ruling out known natural sources, and isolating the unusual cases helps refine the search criteria for future investigations. It demonstrates the complexities of deciphering cosmic signals, where misinterpretations could easily derail the search for advanced civilizations. Despite the new developments, skepticism remains about the likelihood of encountering a Dyson sphere anytime soon. The vastness of the universe and the number of variables involved in detecting such an anomaly make it a monumental task. Theoretical models of Dyson spheres suggest that these structures could take thousands, if not millions, of years to build. Therefore, the probability of observing one, let alone interpreting its radiation correctly, depends heavily on both the technology available for detection and the position of such civilizations in the cosmic timeline. In addition, there is the issue of time delay, as light from distant stars can take millions of years to reach us. This means that any signs we detect could be remnants of civilizations that have long since ceased to exist. Nevertheless, the search for Dyson spheres has broader implications for humanity's future. The concept of harnessing a star's power through artificial structures brings to mind the idea of a Type II civilization on the Kardashev scale, a scale that measures the energy consumption of a civilization. If these 7 stars are indeed linked to extraterrestrial megastructures, it would suggest that civilizations far beyond our own technological capabilities may exist. This realization could inspire humanity to explore new energy technologies, driven by the need to develop sustainable and advanced solutions for the future. In the long run, the study of Dyson spheres may not just provide answers about extraterrestrial life, but also guide us toward the next steps in our own technological evolution. As humanity continues to explore the universe, the potential for discovering other civilizations remains a tantalizing prospect, one that could redefine our place in the cosmos. As our technology advances, the search for extraterrestrial megastructures like Dyson spheres will likely become a more integral part of space exploration. the development of more powerful infrared telescopes and the use of advanced data analysis methods will allow astronomers to refine their detection techniques. In fact, the upcoming capabilities of telescopes like the James Webb Space Telescope, JWST, could be instrumental in pushing the boundaries of our understanding. With its ability to observe distant stars and galaxies in unprecedented detail, the JWST could provide crucial insights into the nature of strange cosmic phenomena, whether they are signs of alien technology or yet unexplained natural occurrences. In this sense, the search for Dyson spheres may not only bring us closer to discovering extraterrestrial life but also deepen our understanding of fundamental cosmic processes. Thanks for exploring the cosmos with us. If you enjoyed this video, make sure to like, subscribe, and hit the bell to stay updated with all things space here at Space Lab. Keep looking up, and we'll see you in the next video.